Oh, paper Feb March 2026, paper 6, variant 2. This is an ATP paper. All right, recent paper of this year. We will start from question number 1. Okay, in question number 1, they are saying a student determine the density of a glass ball. The student pours water into a measuring cylinder until it is approximately half full. Places the measuring cylinder of water on top pen balance, records the combined mass m1 of the measuring cylinder and water. So you can see the combined mass of measuring cylinder and water is 125.6 gram. All right. Now they are saying describe one technique for using a top pen balance to measure the mass of the measuring cylinder and water to ensure an accurate reading. So basically, in this question, they are asking how we can measure an accurate reading with the help of top pen balance. Do you have any idea, students, that how we can determine an accurate reading? How we can ensure that the reading is accurate? देखिए बेटा, suppose that this is a pen balance, all right, which is placed on the horizontal surface. If the horizontal surface is not smooth, it is tilted, so it means that the reading measured by the pen balance is not correct. So we have to ensure that the top pen balance, which we are using to measure the mass of measuring cylinder and water, it should be smooth and it should be placed on the level surface. Otherwise, we will get an inaccurate answer. So we can write here, ensure, we can write this answer, students. Ensure top pen balance, ensure top pen balance is placed on a smooth horizontal surface. All right, there can be many possible answers for this question on a smooth level surface. All right, students. So this we can get the accurate result, or we can write here that we can reduce the systematic error to get an accurate answer. Systematic error means we can check the zero error of top pen balance. Is it clear to you, students? All right. Okay, Ahmed. Now you can see in the next part 3. In part 3, they are saying figure 1.1 shows the water level in the measuring cylinder. Record the volume V1 of water in the measuring cylinder. So they are recording the volume of water in the measuring cylinder. So the diagram is given. This is the water level of measuring cylinder. And when we talk about the water level, so we have to read the lower meniscus or upper meniscus, students. Well done, beta. We have to read the lower meniscus, and lower meniscus is giving us the reading 91. Well done, students. 91 centimeter cube is the reading of lower meniscus. All right. 91 centimeter cube is the reading of lower meniscus. Now they are saying describe two techniques that the student uses when measuring the volume of the water to ensure an accurate reading. So if we are measuring the volume of the water, so what techniques we have to follow to get an accurate reading? So students, you have to make sure that we always read the lower meniscus while measuring the reading of water. Well done, Ahmed. We have to measure the exactly, Zurays. Avoid parallax error. Yes, exactly, beta. In first option, we can write here avoid parallax error. All right, if we will avoid the parallax error, so it means that we will get an accurate reading. Acha, what could be the second option, student? The second option could be read lower meniscus. All right, sometimes the students are get confused that we have to read which meniscus level, and by mistake they read upper meniscus, which will give us inaccurate reading. All right, so read lower meniscus of water to get the accurate reading. Is it clear to you, students? Acha, this type of questions are very important and these are the repeated questions. Okay. I hope you have noted down. Now we have completed part A. Look at the part B. In part B, they are saying the student places 4 glass balls into the water in the measuring cylinder, ensuring no water splashes out. So basically what they are doing, this is the measuring cylinder, all right, and this is the amount of water in the measuring cylinder. And what they are doing, they are placing the 4 glass balls in this measuring cylinder and no water is splashing out. All right, now they are saying the student record the mass M2 of the measuring cylinder, water and 4 glass balls. So basically the mass which you can see here, this is the total mass of measuring cylinder, water and 4 glass ball. Now we have to find the mass of 1 glass ball. So it's a very easy question, students, because already they have given us the mass of measuring cylinder and water. You can see the mass of measuring cylinder and water is given 125.6 grams. So mass of measuring cylinder and water is given 125.6 grams. This is the mass M1. This M1 mass is containing the mass of measuring cylinder and water. Now what we are doing, we are pouring 4 glass balls into the water. So the new mass will become 132.8 gram. This is the final mass. So we have to calculate the mass of 4 balls first. So how we will calculate the mass of 4 balls? We will subtract both of them, M2 minus M1. So M2 is 132.8 gram minus 125.6 gram. So after subtracting both values, what we are getting, students? We are getting 7.2 gram is the total mass of 4 balls. Now, students, we have to calculate the mass of 1 glass ball only. So what we will do? We will divide this total mass by 4 because there are 4 balls. So well done, Suresh. We are getting 1.8 gram is the mass of 1 ball. Is it clear to you, students? Did you understand this question, beta? Assalamu alaikum, Ania. We are solving students Feb March 2026, paper 6, variant 2. Okay, done. Now I'm going to clear the screen and moving towards the next part. In the next part, they are saying the student records the volume V2 of the water and 4 glass balls. So basically what they are doing, they are recording the total volume of the water and 4 glass balls, that is 94 centimeter cube. Calculate the volume of 1 glass ball. We have to calculate the volume of 1 glass ball. So now you can see initially water volume was 91 centimeter cube. That is the initial volume of water. And now water, which is containing 4 glass balls, its volume is 94 centimeter cube. So we have to calculate the volume of 4 glass balls only. So V2 minus V1. V2 is the final volume, which is 94 centimeter cube. V1 is the initial volume of water, that was 91 centimeter cube. What we will do, students, we will subtract both of them. So we will get 3 centimeter cube, which is the total volume of 4 glass balls. All right. Now we have to calculate the volume of 1 glass ball only. So 1 glass ball volume is equals to 3 divided by 4. Why I am dividing by 4, beta? Because there are 4 glass balls. Alright, so we will get 0.75 centimeter cube. Well done, Suresh. So the volume of 1 glass ball is equals to 0.75 centimeter cube. Is it clear to you, students? All right. Now, in the next part, part 3, they are saying calculate the density of a glass ball Use your values from 1B part 1 and 1B part 2 and give the unit as well. So it's a very easy question. We have already calculated the mass of one glass ball. What was the mass of one glass ball, beta? The mass of one glass ball was 1.8 gram and the volume of one glass ball is 0.75 centimeter cube. Exactly, students. Now we don't need to memorize the formula because the formula is already given in the question. That is the good thing about the ATP, that all formulas are given. So density is equals to mass upon volume. So mass of one glass ball is 1.8 and volume is 0.75. After dividing, we will get the answer 2.4. 2.4 is the density. And what is the unit, student? Because we have taken the mass in gram and volume in centimeter cube. All right, so the density is gram per centimeter cube. All right, so density of this glass ball is 2.4 gram per centimeter cube. Have you understood this question, students? All right, excellent. All right, beta. Okay, students. Now, what we will do? We are moving towards the next question, students. In the next question, they are saying, oh, 1 minute. In the next question, they are saying, suggest two improvement that will help a student to determine a more accurate value for the volume of glass ball. So देखिए बेटा, here we have to increase the accuracy of the volume of glass ball. So whenever we need to increase the accuracy, so we have to take the more values of readings. We have to take the more values of bigger values of reading. Like what we were doing, beta, we were taking the measuring cylinder. We have put the volume of water in it in this measuring cylinder and we have immersed 4 glass balls into measuring cylinder and we have found the volume of one glass ball that was 0.75 centimeter cube. But they are saying we have to give the suggestion here that how we can improve the accuracy to find the volume of a glass ball. So how we can make the reading more accurate. So what I will do, students, I will put more glass balls in this measuring cylinder. All right. I will put exactly, Suresh. I will put more glass balls. So now what I am doing, I am putting the more glass balls in this measuring cylinder and the water volume will rise up. The total water volume level will rise up. All right. So what I will do, students, suppose that this is the initial volume of water was 91 centimeter cube. All right, and now the final volume of water we are getting 120 centimeter cube because we have put in more glass balls in this measuring cylinder. So how we can find the change in volume? So change in volume is 120 minus 91. So what volume we are getting, beta? 120 minus 91. Exactly, 29 centimeter cube is the total volume. And suppose that if I have put in 10 balls in this measuring cylinder, so how can I find the volume of one glass ball? 29 divided by 10. So we will get the more accurate volume that is 2.9 centimeter cube. So basically the purpose of telling you this thing that by adding more glass balls, we can increase the accuracy of the experiment. All right. So how should I write the answer? Add more glass balls in this measuring cylinder. Add more glass balls in measuring cylinder to increase the accuracy of the reading. All right. By putting the more glass balls in the measuring cylinder, we will get the more accurate reading to increase the accuracy of the Not reading, accuracy of the volume of one glass ball. All right, students. So this was the only first point. What could be the second point, students? Acha, should I use the measuring cylinder with large range or small range? If I will use the measuring cylinder of greater range, students, so it means it will not give us the reading with precision or with significant figure. Like for example, if I will use the measuring cylinder with greater scale or greater range, so it means that, let's suppose if I'm getting this volume, so it must be 100.20 centimeter cube, but it will not give us the reading in decimal places. So it means it will not give us more accurate reading. Exactly, beta. So we have to use the scale. We have to use the measuring cylinder with a smaller scale to get the more accurate reading. All right, students. We have to use the measuring cylinder of a smaller scale to get the more accurate reading. Is it clear to you, students? Vanya, are you understanding, beta? Ahmed? So we can write the second option here, that use measuring cylinder with a smaller range or a smaller scale. All right, students? Any confusion here? All right. Now I'm going to clear the screen. I hope you all have noted down. I'm moving towards the next question. Question number 2. In question number 2, they are saying a student investigated the behavior of a spring. So you can see this is the spring. This is the meter rule. And this stand is placed on a bench. And we are using the G clamp here to fix this stand. Otherwise, the stand can be toppled. Now in A part, they are saying describe two techniques. We have to describe two techniques the student uses when measuring the length of the spring to ensure an accurate reading. You may draw the diagram. So what should be the first answer, students? Because these types of question has been repeated many times, that how can I get the accurate reading while we are measuring the reading from the meter rule? So we have to keep our eye level perpendicular to the meter rule. Exactly. We will avoid parallax error. We will avoid parallax error. So we have to mention here, student, that we have to keep our eye perpendicular to the meter rule. All right, so I'm writing this answer here, students. Just give me 1 minute. Okay, keep eye level perpendicular to the meter rule. All right, student, we have to keep our eye level perpendicular to the meter rule, or you can write here avoid parallax error. All right, avoid parallax error. So we will get the accurate answer. Okay. Acha, what could be the second accuracy, student? First, write down this option, students. Done. Okay. Now we will use the set of square to get the accurate reading. For example, students, let me zoom this picture first so you can understand what I want to explain you here. Okay. Now, students, suppose that one of my student is doing the mistake. He is unable to find the exact edge of this spring. So might be possible when he will take the reading, there will be an error of 0.1 or 0.2 centimeter. All right. And this edge as well, because we have to measure this length of the spring. So what we will do, we will use the set of squares. We will use the set of square to record the accurate reading. So what I will do, I will place one set of square here at the first edge of the meter rule. All right. And I will use the second edge set of square at the second edge of the meter rule. And I can measure the exact reading by subtracting the final reading from initial reading. So basically, with this set of square, we will get the accurate reading. देखिए बेटा, in this question, they were asking how we can get the accurate reading. Accurate reading. So obviously, when you will do without set of squares, so there are chances of error. So what you have to write here, that we will use the set of squares on both edges of the spring to get the accurate reading or accurate length of the spring. Is it clear to you, students? All right. Now I'm moving towards the next part. We have done the part A, students. Now look at the B part. Next part. In next part, they are saying using figure 2.2, record the initial length L0 of the spring with no load. Now we have to record the initial length of the spring with no load. Do not include the loops at the end of the spring in your measurement. Show clearly on figure 2.2 how you made measurement. All right. So we have to record the length of this spring. So this must be the initial reading. All right. This must be the final reading. And we have to measure the gap between both of them. So that would be the length of the string. And they are saying do not include the loops. So you can see I didn't include the loops here. So what is the initial reading here, students? What is the value of initial reading? I think I didn't draw this line correctly. Just 1 minute. Let me draw it again. Okay, now it's perfect. Now, student, we have to record the initial reading and final reading, and then we will subtract both of them to get the accurate answer. So, what is the initial reading, students? It is 36.3. Am I right, student? It is 36.3. And what is the final reading, student? The final reading value is 38.5. So now we have to subtract both of them to get the length of this spring. So 38.5 minus 36.5. Now subtract both of them, students, and tell me what answer you are getting. Hurry up. Hurry up, students. I'm waiting for your answer. 38.5 minus 36.3. What answer you are getting, students? Am I audible to you, everyone? Okay, all right. 2.2. 2.2 millimeter is the length of this spring. All right, students, 2.2. We are getting 2.2 millimeter, the length of this spring. Is it clear to you, everyone? Easy? All right. Now I'm moving towards the next part. Uh-oh. In the next part, what they are saying, in part B, the student suspends a load L is equals to 1 Newton from the spring. Record the new length of the spring in table 2.1. Alright, so we have to record the new length of the spring. Calculate the extension x of the spring using the equation x is equals to L minus L naught. So you can see what is the interesting thing about the ATP, that you don't need to memorize any formula. All formulas are given. Final length minus initial length. So what was the value of initial length, students? 2.2 millimeter. Am I right, students? Exactly. 2.2 millimeter. We were getting 2.2 millimeter. All right. Millimeter or centimeter? 2 point, I think we were getting the reading 2.2 centimeter because it's a meter rule which is given in centimeter. My mistake, beta, sorry. All right, we have to convert it into millimeter, centimeter to millimeter. So we will multiply it by 10. So we are getting 22 millimeter. All right, students. The reading L naught is 22 millimeter. Please make correction here. It's my mistake, beta. Obviously, meter rule will measure the length in centimeter. So this reading is in centimeter. And we have to convert it into millimeter by multiply it with 10. 1 centimeter is equals to 10 millimeter. Alright. So now we are getting 22 millimeter here. Now I'm moving towards the next part. We have to find the reading of extension here. According to this formula, we have to fill it. So now you can see we were getting the reading 22 millimeter. That is the initial length L0. So for every calculation, we have to subtract the reading L minus L0. So it means 42 minus 22. So what we will get, students? 42 minus 22. What we will get? We have to complete this table, students. Hurry up. We are getting 20 millimeter. All right. We are getting 20 millimeter here. Now for the next step, 61 minus 22. Still, student, I'm waiting for your response. We have to complete this table. 61 minus 22. What we are getting? Come on, students. I'm waiting for your response, beta. Are you present in class today? Inaya, Vanya, 39. All right. Thank you so much. Okay. In the next reading, we have to subtract 82 and 22. What we will get, students? 60. All right. Now tell me the next reading, 107 minus 22. Okay. 85. All right. And 125 minus 22, we are getting 103. Well done, Zuresh. 103. So we have completed the table and you can see this question is very easy. Just you have to do the subtraction and you will get the answer. All right, you have to fill this table. Now in the next part, they are saying see part 1. Plot a graph of load in Newton on y-axis. So it means we have to take the load in Newton on y-axis and against x millimeter in x-axis. We have to start the axis from the origin 0, 0. And we have to draw the best fit line. We have to draw the best fit line. So now student, first we have to label with these axes because they are saying we have to take the load on y-axis in Newton. So load we have to take in Newton on y-axis. All right. And we have to take the extension in millimeter on x-axis. So I'm writing here extension in millimeter on x-axis and we have to start the graph from origin. Origin means we have to start the graph from 0, 0. All right. So now we can see here that the load is given from 1 Newton to 5 Newton. Okay, students? Load is given from 1 Newton to 5 Newton and we have to take the load on y-axis. So you can see how many boxes are there. One big box, 2, 3, 4, 5, and 6. So we can start the reading from 0. All right. Then after 10 small boxes, it is 1 Newton. All right. 10 small boxes, 2 Newton. 10 small boxes, 3 Newton. 10 small boxes, 4 and 5. Or in the last, we have to mark the 6. Remember, beta, graph should be covered 75% of your paper. All right, the graph paper should be covered 75%. Otherwise, there are chances that you will lose the marks. Now you can see student extension is varying from 20 millimeter to 103 millimeter. 20 to 103. All right. So how we can find that we have, you can see how many boxes are there? 1, 2, 3, 4, 5, 6. There are 6 boxes. So if I will start from 0, so 20, 40, 60, 80, 100. So that will be the perfect values. So we have to start the graph from the origin. As they have mentioned here, start the axis from the origin. So now you can see beta, this reading must be 0, 20, all right, 40, 60, 80, 100, and in the last we will get 120. Are you understanding the scaling of this scale, students? Now we have to start the plotting of this graph. So you can see the first load is 1 Newton. Load is 1 Newton and extension is 20 millimeter. So load is 1 Newton and extension is 20 millimeter. So I'm going to change the color. I'm choosing the red color. For load is 1 Newton, extension is 20 millimeter. So we have to place the cross here. Alright. Now students, load is 2 Newton and extension is 39 millimeter. Alright. Let me zoom this picture beta so I can clearly see all the squares. Load is 2 Newton and extension is 39 millimeter. So 39 millimeter will lie in between them. Alright. And load is 3 Newton, extension is 1 minute beta. Extension is 60 millimeter. So load is 3 Newton and extension is 60 millimeter. So this is the extension, students. All right. Now the next is load is 4 Newton and extension is 85 millimeter. Load is 4 Newton and extension is 85. So this reading is 80 and this reading is 80, 82, 84, 85 will must lie here. 85 millimeter, right students? And the last reading is 5. For 5, we are getting 103. Alright, load is 5 and this must be 100 and 103 will lie at this point. Are you understanding this thing, students? Okay, so these are the process which we have marked. We have drawn the graph, students. Now we have to draw the best fit line. So how we will draw the best fit line, students? We have to draw the best fit line. So let me take the straight line here. Can be that. Why I can't find the straight line, students? Oh, this one. Sorry, beta. So we have to draw the straight line here. So which type of line we will get? Any idea, students? We have to draw the best fit line. So which type of line we will get, students? A straight line or curved line? We have to draw the straight line here. Exactly, students. We have to draw the straight line here and try to join the maximum crosses. Try to join the maximum crosses. So if I will place the ruler like this, so you can see all the points are maximum join. All the points are maximum join. So should I draw the cross like this, students? Sorry, straight line like this. All right. So now I'm choosing the straight line. All right. And I will start from the, 1 minute. All right. Now I'm going to start to draw the straight line. So you can see it is joining all the crosses. Yes, it's perfect. All right. And I'm going to remove the ruler. So it is not exactly starting from origin, but just because of my hand was shaking during the alignment. But here we are getting the straight increasing line. Did you understand this graph, students? We are getting the straight line, exact straight line. Okay, now what they are saying in the next part. In the next part, they are asking, state and explain if your line L and X are showing direct relation or inverse relation or whatever relation. So basically, they are saying L and X are directly proportional. We have to prove that. So we are getting the straight increasing line. We are getting a straight increasing line. So what do you think, student? It shows a direct relation or inverse relation? They are using the word state and explain. State means a statement should be yes or no. So what is your answer, student? What is your answer? Is there a direct relation between these two quantities, load and extension? Yes, Vania, what do you think? Yes, they are directly proportional. All right. So first we will write, yes, it is directly proportional because we are getting straight line. All right. It is directly proportional. It is directly proportional So what reason we will write here? Because they are using the word explain here, because it is a straight line. All right, students. We can write here straight increasing line. Straight increasing line, because straight line can be increasing or decreasing as well. So here we are getting the straight increasing lines which showing our direct relation. Clear everyone? Did you understand these questions, students? All right, beta. Now I'm going to clear the screen, students. Okay. And we have done this graph. I'm moving towards the next question, that is question number 3. All right, which is related to circuits. In question number 3, okay, Naya, a student investigates circuit containing different combination of resistors. So what the student is doing? He is investigating the circuit which contains different combination of resistor. You can see this is the circuit 1 in figure 3.1. This is a battery, a switch, an ammeter is connected in series which will measure the current. A voltmeter is connected in parallel combination with this resistor which will measure the potential difference. Alright, circuit 1 contains one resistor of resistance X ohm. The student close the switch and measure the potential difference and current. Now they are asking record in table 3.1 the ammeter, voltmeter and ammeter reading shown in figure 3.2 for circuit. Now we have to record the reading of ammeter and voltmeter. So now you can see, students, that voltmeter reading. How we will find the voltmeter reading? So you can see this line is representing 2.5 because it is line between 2 and 3. So this must be 2.4 volt. So voltmeter reading is 2.4 volt. And what is the reading on ammeter, students? Can you tell me? You can see this line must be 0.3 because it is line between 0.2 and 0.4. So each line is representing 0.2 ampere. Each line is representing 0.2 ampere. So it is 0.3, 0.32 because we are getting line after 0.3. So it must be 0.32 ampere. Are you understanding this thing, students? All right. Now you can see in the next part, figure 3.3 shows circuit 2. This is circuit 2 and there are 4 resistors in this circuit. All right. So this is a battery, ammeter, voltmeter, switch. And now student close the switch and measure the potential